I have to change the denominator. If we forgot this is a problem, right? So x to 3/4 is the fourth root of x to the third. 3 is the numerator, the index is always the denominator. But since it is in the denominator, to put it up, I have to change the power into a negative power. Now this I can integrate. So the indefinite integral of 5x to negative 3/4 dx is not difficult. 5 stays in front. X, I increase the power by 1. Let's write it so we can see it. Divide by exactly the same number plus a constant c. And now I have to perform the calculations, but that's all I needed to do. 5 stays outside. I increase the power by 1. I divide by exactly the same number. And in this case, there is nothing else, so I have to write plus a constant c. 1 minus 3/4 is 1/4. So then I have 5x to 1/4 over 1/4 plus c. It's good because once I calculate this one, I don't have to calculate this. I have to have the same number. I have to flip the denominator because it's a fraction. And I will write 20x to 1/4 plus a constant c. Can I check? I can always check. By differentiating this, I should get 5 over the fourth root of x to the third. I can always check the indefinite integral, always. Okay, so let's summarize the steps here, and then we'll choose another, or you choose another. 5 divided by the fourth root of x to the third, the fourth root of x to the third has to be rewritten as x to 3/4, 3 over 4. Because it's in the denominator, I need to bring it up, but I cannot bring it up without changing the sign of the power. Because x to negative 3/4 is 1 over x to 3/4. Then I apply the rule that says the integral from x to negative 3/4, copy the power, add 1 to it, and then divide by exactly the same number, plus a constant c. When I calculate 1 minus 3/4, it's $1 minus 75 cents, it's a quarter. 1 minus 3/4 is a quarter. So this has to be the same. Since I'm dividing by a fraction, I have to flip it. 5 times 4 is 20, x to 1/4 plus a constant c. And this is done. This is it. Very good pick. Thank you. Good. Let's pick anything else. I would like to pick 27, and then you pick the next one. In 27, we have the integral from 2e to 2x dx. Good. So again, the same idea. We want to find the most general antiderivative, the family of functions whose derivative is 2e to 2x. We had an example a few minutes ago, if you paid attention. If not, it's okay, I'll repeat it. 2 stays outside. Which function prime is e to 2x? Which function prime is e to 2x? Anyone?
E to 2x times 2.
But over 2, because we are reversing. Oh, yes, yes, yes. So very good. Let's go back for a second. So e to 3x, the function whose derivative is this. Because e to 3x prime is e to 3x times the inner function prime, which is 3, which will cancel with a 3 in the denominator, and we get that. Good, awesome, thank you. And of course, you can never forget plus a constant c. We simplify the 2 with the 2, so the final answer is e to 2x plus a constant c. You can say, how do I know this is correct? Very easy to check. When I differentiate this, c prime is 0. When I differentiate this, I have e to 2x times the inner function prime. Any questions? Any questions? Okay. Would you like to choose anything else? Because then I would like to work on these problems. Anyone would like to choose something else? I'm interested in 21, but let's see whatever else, and we'll do 21, but I'd like to see what else you would like to pick. And I'm on page 4. Any preference? Anyone? Any preference? No preference? Okay, in that case, I wanted to look at 21. And 21, we have the integral from 3 over x plus 5 over x squared dx. Same question. We're asked to find the most general antiderivative. In other words, the indefinite integral of 3 over x plus 5 over x squared dx. Now, anyone remembers, so the 3 stays outside. Which function prime is 1 over x? So let me address this on the side. There is one function that we, say it again?
ln.
Excellent, thank you very much. And if you remember a long time ago, we said that we normally have to put the absolute value because there is no difference with and without, but we have to put the absolute value. Excellent, great job. So natural log x equals 1 over x, or absolute value. Awesome. Now, plus 5. Now, I'm looking for a function whose derivative is 1 over x squared with no 1 is this, but with minus. And a long time ago, I said, please try to remember this rule because it's very useful, and it's very useful right now. So when we differentiate 1 over x, we get negative 1 over x squared. When I integrate 1 over x squared, I get negative 1 over x. So when I integrate 1 over x squared dx, we get negative 1 over x, of course, plus a constant c. All I need to do is just remove parentheses here. So I have 3 natural log the absolute value of x minus 5 over x plus a constant c. Let's do this problem one more time. You can say, show me that this works. Perfect. 3 natural log prime is 1 over x. I differentiate 1 over x and I get negative 1 over x squared with minus in front, and I get that. So, however, let's do this one more time. 3 stays outside. How come? Well, 3 over x is 3 times 1 over x. Same thing. So 3 outside. Which function prime is 1 over x? Well, it's natural log of the absolute value of x. And here, we know that 1 over x prime is negative 1 over x squared. And when we integrate 1 over x squared, this is what we're trying to do here. We integrate 1 over x squared, we get negative 1 over x. Negative 1 over x, with 5 in front, of course. So negative 5 over x plus a constant c. It's not difficult, but it requires a lot of attention and practice. So please tell me if you'd like to pick anything else. If not, I would like to look at this set of problems. You choose. Let me know if you want to work on anything else. No preference? Okay, then I would like to move on to the next set of problems. Can anyone pick a problem from these, 47 through 56? Is anyone with me?
51.
Okay, 51. Very good. Let's pick 51. Where are you, 51? Okay, so we have f prime of x equals 8x squared plus 4x minus 2. And we are told that f, the function at 0, equals 6. Perfect pick. Thank you. So we are asked to find f of x. This is the question. We are given f prime. We are given the derivative of this function, which is this. Since the notation is f prime, we are going to use lowercase f of x. We do not need to change it into this symbol or the indefinite integral because we have two notations. One is directly finding the most general antiderivative or the antiderivative, or the other one is with the integral. Good. 8. Which function prime is x squared? Which function prime is x squared? I know it sounds backwards, and I know it is backwards, but we have to try to get used to it. Which function prime is x squared? It's okay if you're wrong. Just give it a shot. Anyone, please?
X cubed over 3.
Brilliant. Thank you very much. Plus 4. Which function prime is x? Give it a shot. It's okay if you're wrong. We're just starting this.
X squared divided by 2.
Excellent. Brilliant. Thank you. Minus. Which function prime is 2? I differentiate something to get 2.
2x.
Exactly. Brilliant. Thank you. Plus, I differentiate something to get 0. What do I differentiate and always get 0?
DE.
Constant.
Exactly, a constant. Awesome. I will try to clean it up a little bit. So f of x equals 8/3 x cubed, 4 divided by 2, 2x squared, minus 2x plus a constant c. Perfect so far. Now look, something else is given to us. So I was given the derivative. I'm able to find that this is the most general antiderivative, a family of functions with all of them have the same derivative. But now the question is, why is this given to us? Why do you think we are told that when x is 0, y is 6? Why? Why is this given to us?
So you can use 6 for c.
To find c. This information is given to us to find c. Once we found c, there is only one function, no longer a family of functions. Only one function whose derivative is this and whose f of 0 is 6. Only one. So the function is 6. The function is 6 when x is 0. 0, 0, 0, c. So then c is 6. So from here we know that the function, the unique, only one function is 8/3 x cubed plus 2x squared minus 2x plus 6. So this was initially the most general antiderivative, but since we were given something called initial condition, then that helped us find the unique c, therefore a unique function. One function that fulfills both conditions, has that derivative, and when I plug in 0, I get 6. There is only one function who does that. So that was the initial condition. The initial condition was given to us exactly as you said. Awesome. Just to find c. Great job. Perfect. Where's my book? I lost my book. Why did I lose my book? Page, okay. So back there, let's choose another with the initial condition. And then let's look at a word problem. Anyone would like to choose? From 47 through 56. And I'm on page 5. Anyone would like to? Anyone? Okay, I will choose 55. We already looked at the problem like this. F prime of x equals 4 over the square root of x, and we are told that f of 1 is -5. In order to find f of x, that's the question, I have to change this into what? How will you change 4 over the square root of x to make it easier to integrate or find the antiderivative? How will you do that? Anyone? Anyone will give us an idea how to change this?
4x to negative,
It has to be a fraction, -1/2, because the square root of x is the same with x to 1/2. Indeed. Thank you, thank you, thank you. Good. So now we're ready to find f of x. I copy 4, and then what do I do next? I have x to -1/2, and I have to add 1 to it. All I have to do next is just copy that number. Good. So 1 minus 1/2 is 1/2. So I have 4 x to 1/2 divided by 1/2 plus a constant c, and I have to flip. So it's 8. And now I can go back to the square root of x plus a constant c. So this is the most general antiderivative. So all these functions have the same derivative. But I am given an initial condition. I am told when x is 1, y is -5. When x is 1, y is -5. So y, -5, equals, when x is 1, 8 plus c. So then how much is c? C equals simple algebra. C equals
-13.
-13. Thank you so much. So then our function is unique. 8 to the square root of x minus 13. Unique. In which sense? Yes, it's the function whose derivative is this, but it's the only function that goes through the point 1 comma -5. 8 to the square root of x minus 13. Okay, so let me share the screen again, and let's take a look